My name is Mac Lobdell. I'm a technical account manager in the Pelion Device Management group within ARM. And I'm pleased to share that Pelion Device Management is now available for the Renesas EK-RA6M3 family. And it's pre-integrated and tested with E² Studio toolchain and flexible software package, the FSP, for Renesas RA microcontrollers. With Pelion Device Management, you get secure identity onboarding. And what that means is that the devices can be provisioned in the factory, can connect securely to the cloud. And you get lifecycle management and update services. So essentially, you can keep your devices configured and up to date remotely in the field. You get a web portal where you can interact with your device fleets, or also you can access the data directly through the REST APIs. You can also license the software to run on-premise in your own servers. It's got built-in security from the ground up, from device to cloud. Pelion Device Management is available, like I mentioned, for the RA6M3 board. It takes advantage of the security features built into the hardware. And it uses a secure boot. You can push firmware updates and have the assurance that it's running authentic software. In today's session, I'll walk through how to set up your tools environment. Then we'll walk through how to build and get your device connected. And then we'll go through how to do a firmware update. So first, let's talk about setup. We're first going to go to the repository of the example application on GitHub. On this page, you'll see a section on setting up the software environment. So the first thing I'm going to do is install E² Studio. Now the installation is complete, and I've thoroughly read all the documentation, of course, and I'm going to launch E² Studio. Okay, going back to our list of software to install, next we're going to install the J-Link software. Okay, the next thing you need is Python and Git, and I already have these installed on my computer. I'm on a Windows computer. I can test this by typing Python -- version and Git -- version to see the versions that I have installed. And then the last step is to download the Renesas Secure Boot package. There are a few more steps to install Python packages. So I'm going to go to my Python terminal, and I'm going to clone a repo from GitHub for the Pelion manifest tool. This is an easy way to get a specific version. I'm going to enter that directory. Then I'm going to install with the Python package manager pip. And I'm going to add a -- user so that it installs it with the correct permissions on my account. Okay, then I'm going to go ahead and install a few more packages from their standard locations. This includes CBOR and the Embed Cloud SDK. I also need to clone this repository, so I'm going to copy the URL, and in my terminal I'm going to use git clone, paste the URL, and it will clone the repository, and then I'm going to change the directory into the repository directory. So this repository includes a zip archive, which is the E2 Studio project that we will be importing in the next step. The next thing I will do is download a developer certificate. Now, developer certificates are used just during development, and they allow you to get credentials that allow your development devices to connect to Pelion, and they don't have to be unique for every device. When you go to production, you'll have a unique certificate created during provisioning time that gets stored securely on your device. To go to Pelion.com, and I'm going to click on the Device Management Console. So to get a certificate, I'll go to Device Identity and click New Certificate. And I'll choose Create a Developer Certificate. I'm going to give the certificate a unique name. Click Create Certificate. And I will choose it on the list and then click Download. To create an API key to access your Pelion account, you can go to the Device Management Console, click on Access Management, click API Keys, and select New API Key. You'll notice that as of last month, API keys are not deprecated. Instead, you can use an access key, but first you have to create an application. So click on Applications, New Application, give it a name, select a group, administrator or developer. I'll choose administrator. Create application. Then click Access Keys. Choose New Access Key. Also give it a name. Select your application that you just created, and then give an expiration date. So we'll allow this access until the end of the year. Then create access key. Then copy this access key and store it securely. Now let's move on to how to build and connect. And referencing the tutorial, I will import the example application. With File Import, General, Existing Projects into Workspace. And then I will select Archive File. And then click Finish. Next, I will locate the workspace for E2 Studio. This is where the project was imported into. And I will copy the developer certificate that was downloaded earlier. I'm going to copy that to the project and overwrite the default file. Then I'm going to click on Configuration XML to generate source code for the project. And finally, I will build the application by pressing the hammer to build. Okay, the next thing I'm going to do is plug in my board. So I'm going to plug in the Ethernet cable and the micro USB on the side here where it says debug. Okay, going back to our tutorial, I'm going to launch the J-Link RTT viewer, and that gives me access to serial data over the debug channel. And I have a few of these installed, so I have to make sure that I pick the latest version. So I choose USB, and then I will choose R7FA6M. Okay, with the terminal connected, I'll go back to E² Studio, and I'm going to launch the debug session by clicking the little bug, and it will download and debug the application. Okay, so it stopped at the reset handler, and I'm now going to press resume to continue the application and just let it run. And it hits main, so I'll let it run again, and now the application should run. So we'll go back to the terminal viewer for the serial data, and I can see that the device application started up and it got an IP address from the network, and it connected to the service, and it registered the Pelion client and got an endpoint name. So now it's communicating back and forth on some of its resources. So if I go to Pelion.com and I log into the device management portal and go to device directory, I can find my device in the list of devices based on devices that are registered and matching up the endpoint name with the device endpoint as displayed in the terminal. So this is my device. I'll click on that, and this is where you can get information about the connected device. You can look at events, things that have happened related to that device, such as connecting to the service. You can look at attributes. These are things that typically don't change, like serial numbers. And resources. So resources are things that can change and are under your control as an application developer. So these are things, they're resources that you define based on your application for doing things like monitoring the devices or pushing configuration information down to the devices. Now I'm going to go back to E² Studio and shut down the debug connection by pressing stop. Now let's talk about firmware update. Okay, we have our device connected and registered with the service, but we haven't yet set it up for a firmware update. So we're going to have to configure a bootloader. We're going to have to set up some certificates for the service to use. So going back to the tutorial, the first thing to do is change our target in E² Studio to release. And this will just set some optimizations for smaller code size. So I can do that with build configurations, set active, release. Next, I'm going to jump to the command prompt where I will run a few commands to initialize the manifest tool, which will generate a unique certificate that'll be loaded onto the device so that the update will be authenticated. And then also it gets the tool prepared for generating a manifest to be used in an update campaign. So I'm going to copy this command and first I'll go into the Pelion Device Management Client folder and I'm going to run this command. And you'll notice that I need to add my API key because this will be reaching out to the Pelion service in your account based on your API key. Okay, so I've completed that step. Now I need to set up the path for the bootloader in the project. So I have downloaded the secure boot application, unzipped all the files. There's 2 levels of zip files. I've unzipped the secure boot package here. Then if I go to E² Studio, Properties, Build Environment, and sboot path, I'll edit the path. And click Apply and Close. Okay, the build is now complete. So we need to flash the bootloader and the application down to the target. And this time we're going to use a tool from Seger called the JFlash Lite. And I have it open here. I am selecting the device. I'm going to click OK. First thing I'm going to do is erase. Okay, the erase was completed successfully. I'm going to tell it the path to the bootloader binary. And we are programming it to base address 0. Next, we're going to program the application. So the file is in the release folder within the example application, and we're going to choose the Pelion DM example signed file. And then we want to program that at base address 10,000 hex. Okay, now I'm going to close the JFlash Lite application. Okay, I'm going to disconnect and reconnect the viewer. And then I will press the reset button on the board. And the bootloader will boot up and it should boot the application. Okay, it's reconnected and registered with the service. So now we are ready to receive firmware updates over the air. Back in E² Studio, I'm going to locate the main file in the PDMC folder. And in the main application function, I'm going to add a simple printf just to make a change in the application. and I will click to rebuild. Okay, that's finished compiling. I'll go back to the tutorial. Now I could go to the device management console and generate manifests, update campaigns, launch the campaigns, monitor their status to update many devices. But this capability is also available through REST APIs, as well as command line tools such as the manifest tool. So in the instructions, there is a command that will actually do almost everything for me as far as launching a new campaign on a specific device. So from within the PDMC folder, I'm going to launch this manifest tool campaign. I have to make sure that I'm pointing to the correct signed binary. And in this case, I'm updating just the one device, so I have to find the device ID, which I can either get through the portal or through the serial terminal from the device. Okay, the device has received the notification that a new firmware payload is available. It's received details from the manifest, so that it can determine that it's a valid update. And it's downloading the new firmware now. It's going to place that into storage. Then the bootloader is going to take over, and it's going to validate that the application has been signed by the authentic party, and then it will boot the application and re-register. And we can see from this line that our change has been pushed out to our device. And now the campaign has completed and the script is auto stopped. Okay, thanks a lot for watching this video. You're now armed with all the information you need to manage your devices. So look forward to seeing what everybody builds. And for more information, go to pelion.com. And thanks a lot for watching.